General vectors. Vectors do not have to have one end tied to the origin, as is the case with a position vector. They can therefore be used to represent the magnitude and direction of the displacement between any 2 points. And in fact, they can represent any type of vector, velocity and acceleration and so on. But let's just think about displacement to start with. So here we have a grid, and we have a point A here, and a point B just here. So we want to represent the vector between those 2 points, and the vector is always a direct line between those points. So to get from A to B, we go 4 across and 1 up, and therefore AB is equal to 4, 1 in component form. We could write 4i plus j. Note the arrow, it is denoting going from A to B. So as we said, that could be written as 4i plus j. Let's have the point C here and point D just over here. And of course the vector CD is represented by this directed line segment. That's 6 across and 2 down. So CD is 6, negative 2 in component form, and 6i minus j if we give it using the unit vectors I and j. There is a 0 vector. The 0 vector, and that would be written as 0 underline if we're handwriting it, the 0 vector is 0, 0. This vector has no magnitude and no direction. So you might think, why do we need it? It's needed for the concept of set closure, which really is beyond the scope of the course. However, it's not difficult to understand. If you consider the vector AB takes you from A to B, and then the vector BA would take you back, if you added them, you'd be back at the start point, so you wouldn't have travelled anywhere. But if you do AB plus BA, you're adding 2 vectors together, so your answer should also be a vector, and that's why we have the 0 vector. When writing the 0 vector by hand, we mentioned this just now, just write it as 0 underlined. You will see other representations, including in the book, but don't worry about that. You just need to be aware of it. For vectors to be equal, they must be equal in magnitude and direction. So here's a vector A. Here's B and here's C. A and B are equal in length, but they're not equal in direction, and therefore the vectors are not equal. A and C are in the same direction, but they're not equal in length, and therefore they're not equal. For vectors to be equal, they have to be equal in both magnitude and direction. If we know that 2 vectors are equal, such that negative 3, 5 is equal to xy, it follows that x is equal to negative 3 and that y is equal to 5. 2 vectors are the negative of each other if they have the same magnitude but go in completely opposite directions. In other words, there'd be 180 degrees between their directions. So let's consider a couple on a grid here. So here's A and here's B. There's the vector between them. And here's a vector that we can see is parallel but completely opposite. So AB is 3, 6, 3 across and 6 up. BA would be negative 3, negative 6. So to go from here, or go to B to A, you'd go -3, 3 to the left, and then -6, which is 6 down.